Okay, so maybe two-step equations aren't as cool as the song, but they're still very, very important. So when solving any kind of equation, of course, your goal is to get the variable alone. The way that you do it is you continue to do inverse operations over the equal sign until your variable is completely by itself. And the why do we need to solve equations? Well, actually, there's too many reasons to list out. I mean, if you go to the store and you only have so much money to spend, and let's say you've already spent so much money and you still want to buy something that's a certain price, you have to solve for the unknown. How many candies can you buy at $2 a piece if you've already spent $5 and your mom only gave you $50, or let's say. Okay, so let's look at one example. I'm going to use the equation 2x plus 4 equals 16. Okay, so think back to your parent functions. If you don't remember, I'll remind you, anytime you just have an x and it's not squared or anything, we call these type of equations linear. Because if I were to graph this equation, it would actually come out to make a line. So I'm looking for what the x value has to be in order for my output to be 16. That's the question. So in order to solve this, it's going to take 2 steps. I'm going to have to undo 2 operations. So the first thing that I like to do is to draw what I call a river, and that's mainly just to keep your equation neat and nice, and all the terms that you need on one side and all the terms you need on another. Okay, so the first term that I want to move is the one that is farthest away from the x. So I'm going to save the term that's closest to the x for last, and I'm going to move this plus 4 over by doing the inverse of adding 4, which is subtracting. And the golden rule, remember, to solving any equation is what you do to one side, you've got to do to the other. So over here, I've zeroed that out. I bring down the 2x. Over here, I have a little bit of solving left, so 16 minus 4 gives me 12. Okay, so now that I'm to 2x equals 12, this is where my step 2 comes in. So this is why it's called two-step. The operation going on between 2 and x is multiplication. Even though there's not a symbol there, when you have a number sitting next to a variable, that implies that these are multiplying, okay? So to undo multiplication, I'm going to do the inverse, or the opposite, which is to divide, and I want to make the coefficient 1. So if I divide by 2, that makes that a 1. And over here, I'll divide by 2. So I bring down that x equals 12 divided by 2 gives me 6. Okay, so I kind of think of this as halfway done because I've just done all of the work, but I'm not quite there yet. What I still need to do is check my work. So to check, you use the original equation. The 2x plus 4 is equal to 16, and I'm going to plug in what I got for my answer. So my checking step's going to look something like this. 2 times 6 plus 4, and this is like a question, like, does 2 times 6 plus 4 equal 16? And the answer is, so this gives me 12 plus 4, and that is true. Remember, an equation is equal because it's the same thing on both sides. If it's not, then we've done something wrong and you have to go back and check your work. Okay, so let's look at another example. This one's going to be very similar, except if you notice here, I have a fraction looking term as my first term I'm adding, and it's supposed to equal 7. So we're going to start out doing the same thing as we did on the last problem. I'm going to draw my river to keep everything straight. And I'm going to start with inverse operations with terms that are farthest away from the variable. So my first step would be to subtract 6 on both sides. I bring down what I have left, which is negative w over 2, and I get 1 on the right-hand side. Okay, so what I see on the left-hand side over here is that I'm still left with a couple of terms next to w. So if you read this out loud, that would read w divided by 2. And the negative could come before. You could say negative w divided by 2. I would probably say w divided by negative 2, just so that I can put these two terms together and get rid of them at the same time. So since I'm dividing, remember we do the opposite to unglue these terms. So instead of dividing by negative 2, I'm going to multiply by negative 2. And what that does is makes that into a 1. The coefficient of w is now 1. And what you do to one side, you've got to do to the other. So over here, I've got to multiply by negative 2. So now I'm left with w equals negative 2. Okay, so there was my two steps. Here was my step 1, subtracting the 6, and here was step 2, by multiplying the negative 2. And again, I'm halfway done, so what I need to do next is to actually check my work. So that's half of it. Now I'm going to go back and check, and you might want to pause the video right here and check that on your own, and then unpause it and come back and see if you get the same thing that I do. Okay? Okay, so let's check. You end up getting negative, and in place of w, I'm going to put negative 2, and then I'm going to continue the rest of the equation. So if you have two negatives next to each other like this, I think of it as like a big ugly plus sign. So that becomes positive. So I end up with a 1 here, 2 divided by 2. So I have 1 plus 6 equals 7. So is that true? Yes, it is. So my answer is correct, and I have completed this problem, and it is the best that I could have done. Okay, another example. So if I have a problem like this, as you notice, I have a term in the denominator over here on the right-hand side. So we've still got to do the same thing. I'm going to eliminate that term before I can do anything else. So what I want to do here, this is x minus 2 divided by 14. So again, if you want to pause the video right here and try this problem on your own, you're more than welcome to stop the video at any time and come back and check your work, okay? But I'll continue. So to get rid of this 14 in the denominator, I'm going to multiply by 14, sorry. That was supposed to be multiplication. So multiply by 14, remember what you do to one side, you've got to do to the other. That makes this into a 1. So now I'm left with 224 equals x minus 12. And that's just a one-step problem. So I would just add 12 to both sides, and I would get 226 is equal to x. And again, check your work, okay? So I'm going to do one more. Okay, here's our last problem. I have 5 halves x plus 1 equals 9. So here, draw my river. I'm going to start with the negative 1. So I'm going to subtract negative 1 on both sides. That makes this 0. And over here I end up with 8. And now I'm left with 5 halves x is equal to 8. So I have one more step to do. I mean, you could break this into 2 steps, but I prefer to do it in 1 just because it's faster. You could do this get rid of the 2 first so you could multiply 2 and then divide by 5. What I like to do is to multiply by what's called the reciprocal. Reciprocal. Reciprocal means that you flip the fraction. So if I have a over b, it's going to become b over a. Okay? So instead of 5 over 2, I'm going to make this 2 over 5. Now what happens when you multiply a fraction by the reciprocal is it equals 1. Because if you notice here, if I multiply these, I end up with 10 over 10, which is equal to 1. So I've made my coefficient 1 in one step. What I do to one side, I've got to do to the other. So I'm also going to multiply this side by 2/5, the reciprocal. And I'm left with x is equal to, and just remember your fraction rules. You can put this over 1 if you'd like, multiply across, and then divide. So you would get 16 over 5. And I don't believe you can reduce that anymore. I would prefer to leave it in that form because the decimal might end up being an approximation, and your fractions are always the exact number. Okay? So thanks for watching. I hope this helped, and remember to check your work. So have a good night, and I will catch you next time.